Okay, today we're looking at verifying trig identities. Same stuff we've been doing the past few days, except now we have a goal that we're wanting to reach. So they're going to tell me what we want to transform it into. Okay, so you know when you have finished. Okay. Alright, so we're going to do 5 examples. We're still following our 6 strategies. We still want to do those 6 strategies. So here's the first one. So I have sine minus sine times cosine squared equals sine cubed. So by verifying a trig identity, what we're doing is we're taking one side of the equal sign, manipulating it, and turning it into the other one. And as a rule of thumb, you want to work with the side that has a little bit more going on. So obviously we want to work with the left side. Okay? It's easier to take something that has more going on and making it smaller instead of taking something smaller and making it bigger. So we want to work with the left side. So which one of my 6 do I want to do first? Which one of my 6 strategies do I want to use? Factor. So I factored sine out. I have sine times 1 minus cosine squared. Bobby? Stagger in. What is it? Sine squared. Okay, and this is where it's good to keep in mind what it is I'm trying to get to, because once I get to this point, you might not know what to do, but if I look to the right, I'm trying to get to sine cubed, so all I have to do is multiply. And when you get it to match up, I want you to write sine cubed equals whatever you're getting to. You don't have to write down that right side every time, but when you get to the final step, I want it written down. That way, we have shown that one side equals the other side. Questions on that one? Yes?
So are you proving that that's correct, or can you just say, like, look at the top part of the initial problem, go, okay, that equals sine cubed, so I'm just going to put sine cubed into sine cubed.
You cannot do that.
So, like, part
You
of
are
the answer is the work.
The work is the answer.
Okay.
So you factor out, you always have a reward.
Well, here's the rule of thumb. If I start with 2 and I factor something out, I've still got to have 2 things inside.
Oh, okay.
All right, next one. All right, secant of x over sine of x minus sine of x over cosine of x equals cotangent of x. Common denominator. So I need to multiply the left fraction by cosine and the right fraction by sine. So I have secant x times cosine x minus sine squared x over sine x times cosine x.
Oh, you can cosine on
Reciprocal, so that is 1. That is correct.
Oh,
I don't know, Bobby. I think you're higher than a 3.
You need to learn you something because now I feel like I'm a level 1.5.
Yeah.
So 1 minus sine squared over sine times cosine. Stagger in.
How'd you get 1?
These 2 things are reciprocals, and whenever you multiply reciprocals together, you always get 1.
Yes, you do.
It's
Okay.
1 cosine times cosine over 1.
So 1 over cosine equals 6.
Correct.
It's messed up. I lost it.
So cosine squared over sine times cosine. I can cancel.
1.
So this cancels with one of those, and cosine over sine is Cotangent. Cotangent equals cotangent.
I'm just like, is that right? I don't know.
Like guessing.
That's
So are there multiple ways to get to the final answer, or is there like
It just
a
wants
one correct way?
no, there's multiple ways.
Okay.
In the end, it's the same thing. Basically, just write down the answer.
Alright, cosine over 1 plus sine plus tangent equals secant.
Can we change that first page on that? Can we change that to X?
Whatever it starts with, that's what I want. Whatever they start you with, keep it.
Yeah, I've already asked that question. Which we have to rewrite it.
Multiply by the conjugate is what we want to do.
Alright.
You just want to put that.
Just that fraction, though, that is correct. So I have 1 minus sine times cosine over 1 minus sine squared.
Cosine squared. Pythagorean.
Pythagorean? I can cancel the cosine.
Makes the tangent sine of the cosine. You already have science cancel.
Oh, this is a minus sign.
They're adding.
1
So it's
minus
negative
sine.
sine.
Sine plus sine.
Yeah, so they would,
I didn't see that.
Yeah.
okay.
Make yourself.
Yeah, and then equals 1 over the x. And then equals
Probably the nicest
So
thing
you're
is
just
that they
proving
No, it's like
the value given.
Question on that one? Okay, keep this in mind. Did anybody think of something else to do at the beginning instead of multiply by the conjugate?
Oh, I was gonna make it just one.
Common denominator, okay? But you got to be careful with that. Usually, if one of your denominators is a binomial, try multiplying by the conjugate first before you do the common denominator. You could do a common denominator and get to the answer, but it's longer. Okay? So try the conjugate first, and if that doesn't work, then come back and get the common denominator. 2 more.
I have an idea, but no, I can't say it.
1 over 1 minus sine plus 1 over 1 plus sine equals 2 secant squared. That's actually going to be the same thing either way. Common denominator or a conjugate, you're going to end up with the same thing in this case. Because what do I have to multiply the left side by if I was getting common denominator?
1 plus sine.
1 plus sine, which is the same thing as the conjugate. So you're technically doing either one at the same time. So that means I'm going to have 1 minus sine squared. I need 1 plus sine on the left, and I need 1 minus sine on the right. Everybody okay with that? I did the conjugate or common denominator, whichever way you like to see it. They produce the same thing.
So the bottom is a Pythagorean.
Bottom is a Pythagorean, and the top goes to 2.
Yup. I got that.
Wait,
Yes.
so how did you get the sign from the numerator and cancel each other out?
Sign minus sign
Cancels each other.
cancels. Yes.
Okay.
And then
1 plus 1 gives me 2. And if I've got cosine squared on the bottom, that's the same thing as having what in the numerator?
Secant.
Secant squared.
This is probably the only
All right, one more.
one I'll get.
This one's got a. We haven't seen this type before, but it still fits in one of our 6 strategies. Alright, that's a 4. Cosecant to the 4th minus cotangent to the 4th equals cotangent, or 2 cotangent squared plus 1. Cosecant to the 4th minus cotangent to the 4th equals 2 cotangent squared plus 1. I don't want to convert. There's actually something else I can do. Factor is correct. What type of factoring?
Plus the minus.
They are. What is that called?
You know, one of the ones.
Pythagorean pair. They are the conjugates.
They turn into conjugates. What's that factoring called?
I don't know.
Conjunction?
What'd you say?
What's your function?
No.
You try harder.
Because one part of that was correct. Part of that
Perfect. Binomial.
Square.
difference.
Just keep
Difference.
spewing out math terms. What
Difference of squares. Difference of squares is what it's called.
Oh, I remember this stuff.
So it factors by difference of squares. Anytime it starts out with something with an exponent of 4 or an exponent of 3, you're going to have to do some type of factoring, more than likely. So keep that in mind.
Now you change. Convert.
No.
It's one of those things. I don't know.
So you factor that.
It's a Pythagorean.
That's a Pythagorean.
Oh.
What does it equal?
Plus 1.
It equals 1. So I'm just left with cosecant squared plus cotangent squared.
Do it again. I'm serious. Do the parenthesis thing again.
Factoring?
Yeah. Can you? Just it says squared. It's just regular.
I can't. You can't do it if it's a plus.
Yeah, it's
If it was a minus, I could do it.
difference of squares.
Yeah, what do you do when it's the addition or sum?
You can't do it.
Squares.
Can't do anything with the sum of 2 squares. It has to be a difference.
No, that's the.
Convert. How do you want to convert?
Well, you said.
Did we convert both or just one?
Okay, here's where we kind of have to do something we haven't done yet. Technically, we've done it, but we're having to do it close. No. And here's where I need to keep in mind what it is I'm trying to get to. I'm trying to get to 2 cotangent squares and a plus 1. How many cotangent squares do I have now? I have 1. Is there any way I can get a cotangent squared out of cosecant squared?
Hold on.
I mean, it has to be.
For not us.
It is a Pythagorean. What?
One plus cosine.
What does cosecant squared equal on the Pythagorean?
1 plus.
1 plus cotangent squared. This is equal to 1 plus cotangent squared.
Oh, it's like the worst one we've done.
So, would it hurt to when you get stuck at a certain point to look at what it's supposed to equal and go,
That's what I said a while ago. Is that you want to when you're working, especially when you get stuck, is look at what you're trying to get to help you figure out what to do next. Okay, majority of the time you're going to be able to follow one of those 6 strategies to get you where you want. In this case, once I get to that point, that's when I need to look and see what I'm trying to get to, and that tells me what to do. Probably.
Oh, Jesus.
So, doing the same thing we've been doing, except now we know what the end result needs to be. You're still using your 6 strategies to get to the end result. So, not much new, except the fact that we know what we want to end up in.
I've learned this. Just kidding. Shut up.
Omit number 10.
Alright. 2 to 18 even, omit number 10. If you want a challenge, number 10 is a challenge.
Is that like a bonus?
Sure.
No.
It's pretty tough.
I bet Nick.
Oh no, I can do it.
No.
I'm just saying, for you guys, it's a step above everything else.
I had no idea.